going to start today's notes with roots of real numbers. And I'm going to start with a couple of just general examples to show you what I'm talking about. For example, if I ask for you the square root of 16, there's an imaginary 2 here that's written that we just don't write because it's the most common. There's actually a 2 here. Saying what number written 2 times is 16. So what's the answer? Right, 4. Okay, and actually we write 4 because technically, if you think about it, 4 times 4 is 16, right? And negative 4 times negative 4 is also 16. But what we study is what we call the principal positive value. You can write yourself a little note over here. We study the principal positive value. And it sounds kind of fancy, but principal positive value. And it just means that if when asked to evaluate, or when asked to find, that's easier to write, I guess, the square root of 16, we only give the positive value. So let's try another example. What if I gave you the 4th root of 81? What number do we write out 4 times that's 81? And for those of you that did your warm-up today, when you listed all your roots, here's your 4th powers. What number to the 4th power is 81? 3. So it means that 3 times 3 times 3 times 3 is 81, correct? So the 4th root of 81 is what? 3. Okay, how about the 5th root of 32? What's the 5th root of 32? What number am I going to write out? If you don't, like I said, if you don't have it memorized, look at your powers, your roots. What is the 5th root? 2. So 2 times 2 times 2 times 2 is 2. So the answer is 2. For those of you who were absent for today's lesson, what you'll need to memorize, okay? What you'll need to memorize, and to help you with this unit, because the unit will have no calculator, are 2 cubed. So in other words, your cubes through 5, your 4ths through 3, your 5ths through 3, and then your squares all the way through 20. Those you need to know. Alright, so let's go back. The last one is kind of weird, okay? So I'm going to give you a little think box for a second. If I tell you x to the 8th raised to the 2nd power, or x to the 8th squared, what's the answer? X to the 16th, right? Okay, so you all agree that this is x to the 16th. So what if I then say, I'm going to go backwards. If I have x to the 16th, and remember there's an imaginary 2 written here. So what I'm asking you is, what number can I write down twice, okay, that is going to give me x to, and you're multiplying, it's giving me x to the 16th. Anybody know? X to the, what do y'all think? X to the 8th, because you're timesing. So in other words, I'm saying x to the 8th times x to the 8th gives me x to the 16th. Do you agree? I know, weird, right? We times up here, didn't we? So the property doesn't change, right? So we're going to times here. What 2 numbers multiply together? Now, what is a shortcut way so you don't actually have to think about it? What do y'all see here? What's the answer? The answer is x to the what power? X to the 8. Do y'all see a little trick I could have used? Good. Divide. 16 divided by 2 would have given me 8. Alright, let's move on with some more examples. If I have the square root of 8, when you're asking for the square root of 8, can I find the square root of 8? Is 8 a perfect square? Oh, I forgot an x. Guys, I'm sorry. The square root of x to the 8 is what I meant to write. I apologize for that. That's much better. Okay. What number is written there that we just don't put? Okay, 2. So the shortcut, this really means x to the 4th times x to the 4th, right? Or to do a shortcut, it's 8 divided by 2. You might write yourself a note there just in case. That's what we're really doing to make it quicker. So the answer is x to the what power, guys? Perfect. 4. Here's another one. If I ask you for the cube root, that means what number written 3 times, right? The square root is the number written twice. So the cube root of a to the 6th power times b cubed and c to the 9th. Let's use what you've learned. Use what you've learned on the first couple. Let's see if you can solve that. You're going to divide each time. And because it's notes, guys, I'm just going to write this on here one time so you'll see it. I'm really doing A, 6 divided by 3, B, 3 divided by 3, and C, 9 divided by 3. Right? Sometimes it just kind of helps to see it once. So my answer then would be A squared, B, C cubed. Right, next one. How about the square root of a negative 16? Okay. What do you think on that one? Can I find the square root of negative 16? No. Why? Right. 4 times 4 is positive 16. Negative 4 is positive 16. Okay. Does anybody know actually what this answer is? It has an answer. It's for what? Good. It's for I. Okay? But we're not there yet. So we're just going to put, for now, okay, we'll call this no, it doesn't have a real solution, right? It's not a real number. It has an answer. It's not no solution. It's just not a real number. The answer is an imaginary number, for I. Okay, so we're going to talk about, before we move on, another very special case. And this special case means if you have an even x root, and then a number inside and an even exponent, when you do the math, you get your number and you have an odd answer. Which seems kind of weird, but I'll explain it to you. So write that down. Even, odd is how you can remember it. Now, so let me start by explaining to you, if I ask for the square root of a negative 3 squared, remember there's an imaginary 2 here, what do you automatically think the answer would be? You divide 2 by 2, right? What does it look like the answer would be? Right, it looks like negative 3, and that's the pitfall that kids make all the time. Okay? But before you write negative 3, and this is the special case I'm referring to. In other words, if the root is even, and inside the exponent is even, okay, and you get it, in other words, 2 divided by 2 gives you an odd exponent, an exponent of a 1, correct? Then you have to use the absolute value. Let me explain what I mean. If I asked you to do this problem and I told you to take care of what's inside of the radical first, what would you write first? You would say that this is the same thing as the square root of what? 9, right? What's the answer? 3. Okay? Do y'all see what I mean? It's very tricky because instinctively we just want to be like, oh, those cancel, and the answer is negative 3, right? But order of operations says no. Okay, a fast way to think about that is this. If you have an even power and an even root, your answer has to be positive. Okay? So if you have an even power and an even root, when you divide, all right, and you get an odd number, let me show you another one that comes into play. Let's see. The square root of x squared. Okay, that one's a little easier, but you have to keep in mind that if there's a 2 here, right? So even, it's going to give me x, isn't it? But what does x have to be? The answer's not technically x. It's what? It's absolute value of x. It's the positive x. Okay, here's another one. If I give you the 4th root of x to the 20th, what you basically need to understand is that this is even, right? 20 is even, 4 is even. What's 20 divided by 4? 5, agree? So the answer is x to the 5th. But in reality, okay, it fits that even, odd rule, doesn't it? In other words, if this is even and this is even, the answer has to be a positive answer. In other words, you want the absolute value of x to the 5th, or a positive x to the 5th. And in here, it's kind of natural because you just think, oh yeah, look, I'm writing positive. But you don't know what x is. It's a variable. Okay? Where it really matters, or where you can really evidently see it, is naturally you want to cancel these two 2's and say the answer is negative 3, but it isn't. It's even, right? And if you divide, in other words, 20 divided by 4 gives me x to the 5th. Well, the x to the 5th has to be positive. Or they'll put absolute value for you to show you it's positive. All right, so these special cases will come into play. Yeah. You have to try to remember it. Because what happens is later in pre-cal, that's the most important thing you have to remember. That it does matter. Okay? If you have a positive and a positive, and you end up with an odd, your answer's got to be, I said positive. If you have an even and an even, your outcome needs to be positive. Because you're going to make this mistake right here. You're going to cancel these and write negative 3. Okay, now let's try a few problems, and when we get to these special cases, we'll put red flags by it. How about that? So 64. That's principal square root. What's the square root of 64, guys? That's an easy one. 8. Okay, we're going to speed up a little bit. Ready? Now then, you put a negative on the outside. Remember, because we use positive principal root, the positive principal value, right? So if it's just written like this, we just write 8. If there's a negative in front, what are we going to write? Negative 8. Good. All right, here's another one. What if I tell you, well, I want both answers? What would you write here? Sorry. Both answers would mean positive and negative 8. Agree? Okay, so let's keep going. All right, guys, those of you watching the video, I'm going to pause it, and you can watch part 2.